want you to be thinking about your experiment you did yesterday. And think back a couple days ago, we thought about for our tanker, there were a few things that were affecting how much it crushed. The temperature, how it affected the molecules, and you told me it affected the speed and the phase. You also said that there was something about pressure inside. And you also told me there's something about pressure outside. So I want you to think about your experiment you did yesterday. I know you haven't finished yet. You'll finish today. But you probably got 2 results yesterday. So I want you to think so far, pick one of these things, either temperature changes, the speeds of the molecules, or the phase of matter present, or pressure inside or pressure outside. How does one of these things relate to the experiment that you did yesterday? So that's your answer question. So you said the colder, the more carbon. Okay, so you're talking about temperature. So you're talking about pressure. And so what did you say about that? Okay, so I see.
5 months.
I see a lot of you talking about pressure. And one thing I noticed is a lot of you were talking about pressure inside the can when you were heating it. Okay, so you have your can and it's on your hot plate here. And you told me about how the pressure was changing against the walls of the can as you were heating it. So you're talking about pressure inside that was caused by the steam when you're heating it. What I didn't see was very many people talking about once I flip my can over, I didn't see much about how the pressure inside was changing. So I want you to continue thinking about that. How does flipping the can over affect that pressure inside? So we have the pressure inside the can while heating, and we have it also when you flip it over in the cold water. Okay, so make sure you're thinking about both parts of that, because if you're only thinking about this part, you might miss something that happens when you flip the can over. Okay, so keep thinking about that. Also, pressure outside the can. A few of you started thinking about this too. And temperature changes. I'm not sure if I saw any of you today, right now, for your entry question, talking about speeds of molecules changing during the temperature changes. So make sure you think about that. And also, phase of matter, liquid or gas. When you're coming up with your results today, again, I want you to think of this while heating and flipping it over part. So you have to really break it into this kind of beginning, middle, and end for each of these categories. Because if you're only talking about what's happening while you're heating the can, it's not really explaining why the can ended up crushing. So make sure that you include all 3 parts. Does that make sense?
Yeah.
So what you need to do today is actually finish your experiments. I think most of you got at least one of your trials done, but you need to test the other 2 conditions. I'm hoping it can really get done in about 10 or 15 minutes. And then on your paper, if you look on the second page here, can everybody flip to the second page where it says explanation? In that part, I'm asking you to draw your pop cans again and explain what was going on. You might want to just draw little pop cans up at the top and then do your explanation underneath each of the pop cans. And I want you to explain those things that we just talked about. The movement of the molecules. So it should be maybe the beginning, the middle with your hot plate, and the water bath where you flipped it over in there. So for each of those, you need to be telling me about how the molecules are moving. What phase of matter is there? Is there water? Is there gas? A lot of you are using the word steam, and so just try to keep in mind that that steam is a gas. So we're looking at the gas in the can. When does that gas become a liquid? And we've also talked about that there's air in that can, and so you're looking at the steam, the water vapor in the can, and the air in the can. And then also tell me what's causing pressure inside the can. And maybe not, you don't have to say what's causing the pressure outside the can, but just say something about pressure outside the can. Is there pressure outside the can? Is that pressure different than the pressure that's inside the can? Okay, so you can include, is there a difference, if you think there is. Okay, so where do I want the answers to these questions? Where? Where? In your explanation box, okay? So you can do small pictures and also try to include these ideas in your explanation box. So let's go back to this one. You said air can get into this can. So why does that make this one different than this one?
I'm having
The air can't get into that one because we tilt it and then the water with the
The water in your hand was warm, but the water in
covers up the area, covers up the
Which one?
This one.
So what happens here?
Like we tilt it and then the water goes down a little bit and there's like no air that can come in. It goes down and then from there the steam I guess just stays in there and it could either expand or something and create it to
Expand?
just go throughout the can.
Okay, so what about the phase of matter? When you flip this over and it's in cold water, what happened to that steam?
It turned into water.
Okay. And so then what happened to the pressure inside this can?
It decreased
Why?
because there was nothing pushing outside, nothing pushing on the sides of the can.
Inside. So then what about this can? You put it in the cold water and you told me that the steam became water inside. But what happened to the pressure inside this can?
It got blocked off from the bottom of it.
What do you mean?
It didn't have no entry.
What, in this can there's no entry? This is the one that you put in the,
It was an entry.
where? But
From
what
the
about,
bottom.
oh, from the bottom? What
Yeah.
about, so, okay. But what about from the top?
The only thing that could get in was air.
Okay. So in this can, air
Can't get in.
and so what's the air doing to this can?
Pushing it.
I don't know. So, okay, and so can you kind of demonstrate, like, or tell me a little bit more about that? Why would the air be able to crush that can?
Because there's no more pressure.
So there's less pressure inside, and you said there's air on the outside that's going on around on the can. And then in this can, air can get in. You told me that. So why does that make a difference? That's what I want you guys to talk about. Why was air being able to get into this can and this can make it so it didn't crush? So think about what you're thinking about pressure. Is there some reason that the air pressure was able to crush this one, but not this one?
No, he just read it.
Okay, so like,
So go ahead and keep talking about that. I need to go check on some other groups, so keep talking about it.
alright. So maybe the air got in there
Yes.
and was
There
like
should be some.
making its own pressure on the can on the inside. And then like when we put it in the water and the air got in, it made its own pressure. The water couldn't crush it because there was still pressure inside of it. I don't know. Aaron, what do you think? Okay, Peter, what do you think?
I don't know, for this one,
For either one of them.
when you put it there in the cool water and then all this, you see the hot water in there, it's like, it gets cooled down so then all the steam cools down and then it doesn't become as, as reactive or whatever. So it just goes down. I don't know how it crushes. Does it crush?
So you guys are done here?
It thought it was too high, so I thought it should cool it down.
So I want you to think about those molecules. You
Water
said
sinks.
when it's here,
I just turned it off though.
okay, when it's here you have steam. And what's that steam doing inside the can?
It's like pushing on the, it's causing pressure on the inside of the can by pushing outwards.
Okay, now I put it in here and that steam that once was putting pressure and pushing outwards.
Is a liquid and it's not pushing outwards, it's just there. And the water is like, yay, let's go in the can.
So what's the water doing?
Going in the can.
But why?
Because there's nothing coming out of the can. There's nothing stopping it from going inside of the can.
Why nothing stopping it?
I don't know. Why don't you tell me, Vernon?
Why isn't that stopping it anymore?
I shouldn't have said that. I have no clue, honestly.
Because the gas is a liquid, there's nothing coming out of the can. There's nothing putting pressure on the can anymore. It has space to go inside.
Okay. So I want you to go try to put that into a picture and words on your paper, okay? And I think that could help you also explain why, when you just left it open and you put it in here, why it didn't crush also. So continue to think about that change in pressure in the can and how having this open and allowing something to go in is different than when you put it like this.
Okay.
Can I bring a
So Javier was saying it has lots of space now in this can. So I want you to think about why that caused it to crush.
Wow, we waited all the time. There's nothing stopping it.
What stopping what?
Waste of from crashing.
Maybe it has to do with the heat, how hot it is inside. Like how I said, like there's still steam in there, and then it gets colder, so it turns back into water, and
Okay, yeah.
and then like since this part is cold or something, I don't know. Like the thing that's making it like stay up is the pressure.
Okay, so that's what originally makes it stay open, not crushed, is pressure from where?
On the steam.
From inside the can? And so then when you flip it over and you cool it down, what happens to that pressure inside the can?
Goes away.
So then why is it allowed to crush?
The outside.
And what?
So the surroundings.
Okay, so and what from the surroundings?
It's cold.
So inside, or okay. So I want you to keep thinking about that because you just told me that now there's not as much pressure inside the can, which was it originally was keeping it out. So then why is it now able to crush when you flip it over? What from the surroundings is making it crush?
The air around it.
Okay, what about the air around it? Can
It
air?
puts pressure on it, man.
Oh yeah, that's a great idea. Why don't you try to put that down into words
Yeah.
in a picture? Good.
I had the kids draw pictures of the tanker, and they've done the can crushing experiment and drew some representations of that. And then they did this assignment related to the can crushing. Tell me a little bit about what you think your kids are understanding, and where they're struggling to understand different pieces.
Okay. Well, the first day drawing those tankers, they definitely were kind of all over the place. There were some groups who had a pretty sophisticated, and not sophisticated, but they definitely had a lot of the variables. They thought about pressure differences, they thought about temperature, phase changes. So I think one group really got a lot figured out just by thinking amongst themselves. And it ranged all the way down to a group who really couldn't think about what was going on inside, and they had a really hard time explaining what was going on. And
That was
actually,
a group that just drew the gases.
yeah, they
on
just
the
drew
inside.
a tank and then they just colored it in and said there was gas in there, and then they drew a squished tanker, and they didn't even draw anything in that bottom tanker. They just couldn't even think about what was happening, or they didn't think about what was happening. And that group, I think, has some students who are having a really hard time, like as the student said, I don't know, I can't see it. Like I can't explain what's happening because I can't see it. So I think they're having a really hard time. It's kind of an obstacle for at least one student in that group, the fact that he can't see it and he doesn't want to. It almost, makes him shut down. So I think that is one challenge for him, and it's also a challenge, I think, for a lot of students. I'm seeing in this work that they did with it's after they did their own investigation about the pop can, so each group had a different variable that they were testing. They, on the front page, had to tell me their results, and so a lot of them kind of made a data table or drew their cans. On the second page, they were supposed to do an explanation and explain why. And I see in most of the students' explanations section, it's still just a results section. So they say, they redraw the before and after for each can, or they kind of underneath the can will write what the conditions were, the 3 different conditions, but they aren't really saying, they're not doing anything to explain why it's happening in a lot of them. There's a few exceptions. but the prompt is to use drawings of molecules, arrows, and words to explain why, and most of them are still kind of just diagramming how the can is crushing or showing me what it looks like. So that seems to be a challenge for a lot of students, is to really draw out their explanation.
Which is what you've been doing a lot in class.
Yeah, so we've been doing a lot verbally, and it's a lot, I feel like they're a lot better at doing it verbally, especially with kind of prompting. But there's still some things that I keep hearing that I think are getting in the way of their good explanations. Like, for example, a lot of students are still thinking or using words like pull or a suck, so the can's getting pulled in or sucked in, and they're not really, I mean, I guess in kind of a common description that is what's happening, but it doesn't explain what's happening. So to say that it got sucked in or crushed in doesn't really, it's not explaining it.
What would you rather hear them say?
I'd rather have them be talking about a difference in forces, so difference in the pressure outside versus the inside.
So is there
Or at least talk about a push from the outside as why it's getting crushed, instead of the molecules, when they fall to the bottom because they're becoming water, are pulling that can along with them. And that's one that I've heard from several students, and even after we'll talk about, like, if I'm going to pull you, I have to be like holding on to you and you're coming this way with me. They still think later, they go back to the idea that it's a pull instead of a push. So they'll think, oh yeah, it has to be holding on to it for it to be a pull. And they'll say gas molecules aren't holding on to the can. But then, like, later, they'll call it a pull again. So that's
so they're able to reason with the temperature change, and then they're able to reason with going from a gas to a liquid.
Well, some students, some forget that, and I think that
Or they're skipping that
they
step.
skip it. And sometimes when I push their thinking, they'll say, oh, I'll ask them something like, well, what happened to that gas? Is it still a gas when you cooled it down? Because they'll say something like it slowed down, it's moving around less, or it went to the bottom of the can. And then if I ask them, they'll say it's a liquid, but, and not all, but a lot do that. And so I think maybe they think it's obvious, or maybe they remember when I ask them, but it's not something that's always is showing up in their explanation of what's happening, even though I think they know it. But they're not always connecting it to what's happening in that can.
Because it seems like then some of the kids are able, when they're talking about it going from a liquid to a gas, then it's like that phase change is what's causing the pulling down.
Yeah.
Or there's
They
the
say
molecules.
the molecules pull it down when it becomes a liquid.
So how are you reading this, and what do you think you'll do about it?
Well, I had anticipated that pressure would be a problem, like thinking about pressure would be challenging, and it is. Some students, like even on the first day, did think about pressure, differences in pressure. There was the group that thought about the air foot being like stomping on the can, and I think they actually did have some ideas, because they said the can or the tanker that wasn't crushing the air foot wouldn't be able to stomp because the pressure inside was too much, and they said the other one, the pressure was less, so the air foot could stomp it. But so this idea of the air foot is interesting, and kind of like a good explanation, except for, of course, there's not really an air foot.
Yeah, it's coming from the outside.
Yeah, and so there's air molecules all around it, and that's just from the top, and so it's something that would need to be very kind of teased out, I think, what they're really thinking, and still relate that to pressure of the gas molecules outside. Because I think they thought of that because we talked about, well, what causes something to crush, but they didn't necessarily have any reason to think that air could crush something.
Do you think it might be an entry point into talking about pressure with them?
Yeah, I think so. I think a lot of groups, when they heard that, kind of thought, that's an interesting idea. So, I mean, it could definitely be something we could refer to again.
So what else are you seeing in their work?
I'm seeing that this bottom question, and maybe I didn't ask it very well, but I wanted them to like make a connection to the tanker. So from what they learned from the pop can, and a lot of them didn't make a great connection. For example, this student is in the group that tested different amounts of how long they heated the can, and so they were amount of steam, although at first they kind of were thinking it's just how long it's boiling. And anyway, they measured it, and she kind of tried to do an explanation here about space and gas escaping and speed of molecules, but it's not very well kind of connected together to her results. And then the way she connected it to the tanker is that they both are thin metals being filled with gas and being cooled down after with the gas being sealed. And so there's no I'm not sure if she really thought about how her results affected the tanker. And so I think I don't know.
Are they
if
able
they're making
to
a
state
connection.
a relationship? Like, so they each looked at these different factors. Are they able to state what that relationship is? Or say the
doesn't-
general pattern? I'm wondering if maybe they need one
Yeah,
learn.
so let's, in the question up here under results, this one says the cooler temperatures would make the can crush faster. The tub had a harder time keeping a warmer temperature than a colder one. So that group found that the temperature in that tub did affect it, and they made a relationship. It said if there was less water in the can will implode more.
So they are able
So they're
to do
able
the first step.
Yeah, they can do the first step. They're saying they can summarize the results and say, if I did this more or less, it made the can crush more or less. But
So they're
then
getting the
explaining
what
why
happened.
on paper is really challenging.
So what are some moves that you think you'll do to help the kids both work with pressure more, but also to work on their explanation writing?
Yeah. Well, I'm going to have to think about that, how to help with explanation writing. I thought that asking them to include the different points that we had talked about, like please include in your explanation temperature, how temperature and phase changes, and speed of molecules, and pressure inside and pressure outside.
Yeah, that was a nice scaffold.
But that was kind of last minute. It's not on their paper, so that's maybe why they didn't do it. But I think that we need to talk a little bit more about what an explanation is, and maybe even do a mini lesson on what an explanation is. I think that would be helpful for them. And then for pressure, I want them to have some more experiences with pressure. I also had them do a reading assignment about pressure, so they could kind of like just so they could read about it. I think that a lot of them just haven't thought much about pressure, and so they could kind of see the language of how we talk about pressure and what is pressure. And
did the reading talk about what causes pressure changes at all?
not what causes pressure changes. It's just what is pressure, and so it talks a little bit about like how humans have air pressure on them and we don't notice it, and if you go up a mountain your ear pops, and so it kind of makes a connection there. And it talks about a simple barometer and how the mercury will fall out of the tube unless the air is pressing it in the pan, like pressing it back up. And so I'm hoping from that they will start also to think about these balances of the forces of pressure. So I'm hoping that will help.
So how do we help them think about move away from this sort of alternative conception about the gas molecules pulling the tank or the can down?
Yeah. Well, I think that we need to talk a little bit more about forces and kind of that balance of force. And I'm hoping that like if they have some experience with different kind of balanced and unbalanced forces and air pressures, that they can make that connection then.
And that's so Monday is that sequence then of different pressure experiments that they're going to
they'll look at different stations. They'll look at different ways to change pressure, and kind of, I'd like them to think specifically at each station, like when, about this balancing of the pressure inside and outside, or.
So it really becomes a challenge of not just thinking about what's going on inside the can or the tanker, but really thinking about what's going on outside, so that they're really having to do both of those pieces at once.
Because that has the gas outside, and it's also something that they don't think about, but the
Yeah.
inside and outside is.
That was something I was thinking about too, is whether, and I saw you pressing on that in class last week too, about how them reasoning
yes.
with whether it's air
that's a
or
big-
whether it's steam.
Yeah, air and steam, and
Uh-huh.
also something I've noticed is that I don't think I've heard any student on their own explain, like, I have a pop can on a hot plate and it's open, like the open versus closed system, like why is it important the air can get in or not get in, and how is that balancing the pressures? So I think actually maybe one or two people have said something about pressure and negative pressure and things like that, but I don't know about specifically about that can being open, and the one group who's testing like the amount of sealedness that the can has is starting to think about that, but it was definitely a challenge for them to think about why it's even important, like what can get into that can, and how is that air important. So air entering the can or leaving the can, how is that important?
It's almost like they need a picture. I was just thinking about, like, they need to draw the air molecules inside, but they need to draw them outside too.
Yeah.
So they're picturing that this is air around us too.
And so I'm hoping from the reading that they did, they'll start thinking about those air molecules like bombarding our bodies and us not thinking about it. And I'd like to prompt them to really start adding those air molecules outside too. You need to get out your journals and your yellow paper from Friday, and then I want you to think back to your experiment from last week with your cans. Each group had a different experiment. I want you to think back to how did changing your manipulated variable amount or affect the amount of crushing. Most of you already summarized your results on your paper, and I handed those back. So think back. You could say when something increased, the can crushed more because, or when something decreased, the can crushed more. I want you to tell me, state your results kind of in a rule, like what caused the can to crush more or less? Okay, so when your temperature drops?
Yeah, because what
What do you mean by when the temperature drops? When it's like colder water? Or what about like when you put it in the hot water?
then I guess it's the opposite.
Okay, so you could say, when I decreased the temperature of the water, then when I changed the temperature of the water bath. Okay, so let's talk about what kind of rules can you say? What did you see when you did your experiment? What caused the can to crush more or less?
When you add more water.
Okay, so when you add more water, is that the experiment you did?
Huh?
Is that the experiment you did?
We did the one. Which one?
Size again.
We did the size of the can. Oh yeah, but when we added more water. That wasn't part of our experiment though.
Okay, so you did both. So when you added more water, how about, can we let the group who did that for their experiment on Wednesday and Thursday talk about that one? How about let's talk about your sizes of cans. What did you see?
The smaller can, like the medium can, like for how much water we had in it crushed more than the larger one and the smaller one.
Okay, and why do you think that maybe was?
Because I say it depended on how much water was in the can.
So it had something to do with the amount of space that was in the can, right?
Yeah, like I don't
And
know.
to the amount of water. And so how about somebody else from that group add to what you were thinking about that?
I think that the can didn't crush as much because for as much water was in there, there wasn't enough pressure created in the cans. so it didn't crash as much when we flipped it over.
Okay, can you talk a little bit? So they had those 3 different sizes of cans, and they said that when you heated it up, because all 3 cans had the same amount of water, and so the larger can, you said, I think on your paper, that they all had about the same amount of steam, right? But how much space that steam was taking up, because you put the same amount of water. And so the amount of space that the steam was occupying affected how much the can crushed. Okay, so the amount of space. And so the amount of space occupied by the gas affected the amount of pressure inside the can. And then when you flipped it over, you cooled down that gas and you got that change in pressure. So amount of space occupied the gas, do you think more space? Was more space or less space causing more crushing? Okay. I'm not really sure how to change that here. Amount of space occupied by gas. How about I just do that? We'll add to what we think that means later. Okay, so what else affected how much the can crushed?
Whether it was sealed or not.
Okay, whether it was sealed or not. So the amount of sealed, how sealed it was. Okay, can you tell us what results you got?
When it was completely sealed, it crushed. When it wasn't sealed at all, it didn't crush. And when it was sealed a little bit, it just made a funny sound.
Okay, it made a funny sound. And also what happened. So they took a can, they took it off the hot plate and put it in the water, straight up and down. They flipped it, and then they put it sideways. And she said the one that's sideways made a funny sound. Can you describe the sound?
Burning.
What was the funny sound?
It's like,
Make the sound.
I don't know how to make the sound.
Yeah, you do.
We'll wait forever.
It made like a suction sound. So they said if it was more sealed, they got more of a crush. And do you have what are you thinking about why?
Yeah, I haven't done that.
Okay, so we haven't gotten to a why yet. So we're going to keep thinking about that. But so far we said the amount of space, whether or not it's sealed affects it. What else? There's 3 more groups. Carter, what did your group find?
We found that, what's just the... This water, like, makes more room for steam so it can crush more.
Okay, so you put different amounts of water.
Yeah.
And the less water you put in the can, the more it crushed.
The more it crushed.
Because you think there was more steam.
Yeah, there was more room for
steam.
steam.
Okay, so the more
It boiled faster.
room
And it boiled faster.
for steam equals more crushing. Does this go with this group? So when your group, when you said the amount of space, when you had more space for the steam, you also got more crushing? Okay, so we can see how these two are maybe related. Good, thank you, Ricardo. Who else? I need 2 more groups to share. Okay, so the colder the water bath, the more crushing. And do you have an idea of why?
Oh. No, I don't know. I just said that it was more pressure when it's colder, so.
More pressure where?
Around it and on the inside too, I guess. I don't know.
Okay, so
Different kinds of
there's something about if we get it colder, we're getting more crushing. And Carson said he thinks there's more pressure outside the can.
Yes.
Do you think the pressure outside the can can change because of the temperature?
No, I don't think so.
Okay, so you don't think it, why would it change?
Because the inside is the only thing that is different, so why would the outside change?
Okay, that's a good point. So I want you to think about maybe where is the pressure changing? So where you think the pressure changing inside?
Yeah.
So what's happening to the pressure inside your can when you cooled it off then?
More pressure.
Because of the air change.
More pressure inside the can?
It's like, oh, I guess less pressure.
Okay, so maybe there's less pressure inside the can when you cool off, the colder it is. Okay, so it's the same pressure. And then our last group, who's the last group? representative here?
More time, the boiling time was increased, the more effect it got. But once the water reached its boiling point, there was no more gas that developed, so it started kind of evaporating.
Okay.
So it didn't give it much effect as the time before it.
Okay, so they heated their can, they put the same amount of water in, they heated it for 2 minutes, 4 minutes, and 6 minutes, and they found that actually the 4 minutes one crushed the most. And what did you decide heating it, what were we changing about what was in the can as you heated it?
The amount of water increased because it wasn't evaporating.
Okay, so you were changing the amount of water, and as you decreased the amount of water, you were increasing the amount of steam. And so you found that if you had more steam in your can, what happened?
More crush.
Okay, so they also found that if they heated it longer, they got more steam, and they got more crushing.
Fruit cake.
Okay, so we're going to keep working to figure out why we got these 5 results.